As the Peoria metropolitan area continues to experience more frequent, higher intensity storms, our area streams have become more susceptible to erosion. The video on your screen was taken during a high intensity storm from the Farmington Road Bridge over Dry Run Creek, very close to the project I will be discussing with you today. The project we will be discussing is GPSD Project 2641, which is named Erosion Control Number 2, located within Laura Bradley Park and adjacent to West Parkside Drive in Peoria. At this location, a 48-inch and 60-inch sewer, along with several manholes, are in jeopardy of failure due to past and ongoing erosion. In a few seconds, we will take you on a brief tour of the eroded stream while we talk more about the project in detail. As previously discussed, many of our largest sewers fall along or within stream and creek basins to allow for gravity flow. This approach has allowed for the collection of wastewater flows without the cost of expensive pumping stations. This approach, while being very economical, has a drawback. Stream and creek beds and banks are prone to erosion. This erosion can lead to catastrophic failure of adjacent sewers due to washouts, debris impact, and undermining of the surrounding structural soils. If this potential damage is not recognized or repaired, the sewers will eventually fail and result in ecological impairment of the receiving stream due to wastewater pollution. Due to this concern, GPSD regularly inspects and monitors sewers near streams and creek basins. As a result of this routine inspection and monitoring, GPSD engineers have identified an area where failure of a large diameter trunk sewer will likely occur if work is not performed to stabilize the erosion. This location is within Dry Run Creek East Branch, within Laura Bradley Park, adjacent to Parkside Drive, as we discussed earlier in the video. GPSD has worked with local engineers, contractors, the Illinois Department of Natural Resources, the U.S. Army Corps of Engineers, and the City of Peoria to develop and permit an ecologically responsible approach to repair and stabilize the creek and sewer. GPSD is using a comprehensive engineering approach using two different methodologies to permanently stabilize the creek. This approach includes using hydraulic countermeasures and hard armoring solutions for permanent stabilization. Hydraulic countermeasures are localized improvements to a stream or creek basin where the geometry is modified to change the amount of energy stored within the flowing water, similar to how a speed bump works on a road. Prior to the installation of a speed bump, a car can travel fast down a stretch of road since they don't have to slow down or stop. When a speed bump is installed on a road, a car must slow down or stop for the speed bump. If the car does not slow down or stop, the impact from hitting the speed bump changes the car's energy from moving forward to moving upward, which results in a net loss of forward velocity. Water works in much the same way. If we install a speed bump, which is often referred to as either a weir or grade control structure in a stream, then under low flow conditions, the water must slow down to go over the speed bump or weir grade control structure. Under high flow, the water can pass over the speed bump, but the direction of the water's momentum changes and reduces the water's available energy to cause erosion. Hard armoring acts differently, but in a way just like it sounds. It entails evaluating areas of stream or creek basin with extremely high velocities, typically 12 feet per second or greater, and replacing existing stream bed and bank material, which is subject to erosion, with an erosion-resistant material such as large boulders or concrete mats. With any project of this nature, citizens rightfully ask questions such as, what's the timeline? How long is this going to take? What's the cost? And have you analyzed the environmental and ecological impacts to a stream prior to performing this work? When it comes to timeline, GPSD is proposing to complete this work within the 2021 calendar year. The actual work will likely take between 3 and 4 months, but due to material availability constraints, COVID-19 working protocols, and potentially unpredictable weather conditions, the actual timeline is subject to change. In regard to cost, the district estimates the cost will be between $1.3 and $1.6 million. However, until final bids are received, these are just estimates. To ensure that the district receives the best possible pricing, this project will be publicly bid and will be awarded to the lowest bidder that meets all required bid conditions in accordance with district policies and state statutes. In regards to the environmental impacts of the stream, the district has employed cutting-edge engineering analysis tools and worked extensively with project stakeholders and regulatory agencies to ensure that this project complies with all applicable state and federal requirements. This has included a full analysis of the impacts of the water flows in the stream, a structural analysis of the improvements to be constructed, and an ecological changes to the stream corridor habitat. In fact, the U.S. Army Corps of Engineers determined during their review that this project would create a net watershed benefit to Dry Run Creek through the reduction of erosion and sediment transport. I would like to thank you for joining me and learning about this important project.